Okay guys, we're starting here. Now, there's something that you need to know about the unit circle, okay? Well, that's a rectangle for a start. Unit circle, okay, is you have your four quadrants, okay? And your four quadrants are going middle and then across, okay? So you have your XY axis. Now, what can happen is, if I say that this is a radius of 1. So see the way the radius is 1? Yeah? Okay? Now, before I say it's radius 1, it's usually a radius of r. Now, I can have any coordinate on this circle can be denoted as r cos theta is the x value, r sin theta is the y value. Now, let me explain what that means. If I have a radius of 3, okay, and I have an angle of 60, where this point will be located on the xy plane is basically 3 cos 60 and 3 sin 60. Now what would those two numbers be? 3 cos 60 is root 3, sorry, is...
Oh, it's 3 root 2.
No, it's a half, isn't it? So it's 3 over 2, and the other one is going to be 3 root 3 over 2. Okay? So basically, what it does is, it can give you the position of, it gives you the position of the end of the tip of the radius at any point you want. So look what happens, for example, if I get this line, I move it into this one here, and now I'm going to instead it's going to be 150 degrees this time. Okay, so the new angle, and the angle is always taken from the start. Okay, let's call this 150. The radius is 3. What point is this here? Can anybody tell me? It's going to be 3 cos 150 and 3 sin 150.
These are based on our complex numbers, like what we would have done.
It's not complex numbers though. Huh?
Okay. Yeah, no, I mean, just like usually what you would do is 180.
Long story short here, you wouldn't get the same answer using 30 degrees instead of 150 degrees, okay? So you put that into calculator. What's 3 cos 150?
Minus 3 root 3 over 2 right here.
Minus 3 root 3 over 2. And that's what we're expecting, isn't it? We're expecting a minus x value and a positive y value. And what's the y value going to be? 3 over 2. Okay? Let's go again. Let's go further along our angle down here. Okay? Let's make up a different one. Let's go for 225. So it's a 225 degree angle now. Okay? What is this point here? If the radius, we're going to change the radius this time. This time the radius is 5. What is the location of this point here then on the xy plane? 5 cos theta and
5 sin theta.
And what is theta?
5.
So what's 5 cos 225?
Minus 5 root 2 over 2.
So 5 root 2 over 2? Yeah, negative x value, and it's also going to be a what, guys? A negative y. And the negative y is the same thing. Now, so you can see that this generic formula, what it does is, it helps us find, we can use a circle and an angle to find the xy coordinate of any point on that circle. Does everybody understand that? I can give you the radius, and I can give you the angle it goes through, and then you can find out what point does that radius end at on the xy plane. Is everybody on board with that much? Okay. Now, we're now going to go back to what you're going to see here, and this is in your notes. You're going to see that it's that's going to be any point on the circle is r cos theta or sin theta. Okay. And what we're asked to prove is, we're going to be asked to prove, this is a formula 1, okay, it's the first formula. And what we're going to be asked to prove is this. We're going to be asked to prove that cos squared A plus sin squared A equals 1. That's what we're going to be asked to do. Okay, so here's what you can do. There's two possible ways of doing it. First way is to say that let r equal 1, radius is now 1. This means what about the point? It means it's going to be just simply, it's simply going to be cos theta and sin theta. Happy with that? Now, This means that if you're to draw a triangle like this, okay, we can do this two ways. You can do it by Pythagoras' theorem, or you can do it by the distance formula. Okay, I'll do the distance formula because distance formula really makes sense here. Okay, so the middle is 0, 0. So the radius is equal to the distance formula of x2 minus x1 squared plus y2 minus y1 squared. Just 1 second. That's going to be x2 y2. That's going to be x1 y1 is going to be 0, 0. And all you have to do is say that your radius is what in this question? Radius is 1. So 1 will therefore be equal to the square root of x2 minus x1. So it's going to be cos theta to be squared, because it's minus 0, so it doesn't matter. And the other one's going to be sine theta minus 0, but does minus 0 matter? No. And then all you have to do is square both sides then. You're going to get 1 equals, there's also one other thing I forgot to do there. Technically speaking, I'm just after proving cos squared theta plus sine squared theta equals 1. If it asked me for A, I'd just say, look, that's angle A. That in turn makes this A, and this one here A. Then you just go back down and say, well, look, that's an A, that's an A, that's an A, and that's an A, and I've proved what I've been asked to do. Okay. Second way of thinking about it. Okay, that's proved. That's one of the proofs done. Second way to think of it would have been that you could have done Pythagoras' theorem, where the length of here to here. So I'm going to mark this in purple. The length of here to here is the x coordinate. It's cos A. The length of the red part, sine A, and then by using Pythagoras' theorem, you'd say that cos squared A plus sine squared A equals 1 squared. Hence, yeah, both ways are acceptable, either using the distance formula or Pythagoras' theorem. Okay, so